In this video, we are going to learn how to measure angles and really learn a lot of things about angles. When naming an angle, you always have to identify the vertex first. In this angle, point F is the vertex. The reason why point F is the vertex is in order to make an angle, you have to have two rays meet. See? This ray and this ray meet at point F. So point F, it's kind of like the elbow or the joint of this angle. That's where the vertex is. It's where the two rays or line segments that form the angle meet. So you just have to identify that vertex first. That's so important. Now we're going to look at 4 different ways to name this angle. Well, the most simple way is just to call it angle F, because F is the vertex. That's why it's so important to identify the vertex. So we could also call this a couple of other names. If you think about it, you kind of start at point H and then go to F and then walk to G if you were to walk on this angle. So we could actually write this as angle H to F to G, angle HFG. We could similarly start at point G and walk over to F and up to H. We could call that angle GFH. Now notice in all 3 of these examples, F is the middle letter. Why? Because it is the vertex. Would it be acceptable to call this angle GHF? Let's see how that would be if we kind of walked it out. GHF, oh, that's actually making a different angle. That would be putting the vertex at H. So that would not be a correct way to name the angle that we're looking at. There actually is a 4th and final way. Again, if you focus on the vertex, there's a point there, but there's also a number. So we could call that angle 1. Now, these are the 4 ways to name this angle. Notice how we use the angle symbol. And that came first, because when we read this, we read it as angle F. We wouldn't write it as F angle, you know what I mean? So be mindful of that detail as well. And remember, always focus on the vertex. Even this 4th and final way, we are focusing on the vertex. It's just that that number happens to be inside, because we're kind of looking at the measure of the angle. Now in this example, let's say that we wanted to name this angle right here. Would it be acceptable to call it angle P? Well, P is the vertex. However, it's also the vertex of this angle right here. And oddly enough, P is also the vertex of this straight line, or this straight angle, going from Q to P to N. So P is the vertex of the angle on the left, the angle on the right, and this entire straight angle. So if we say angle P, we aren't necessarily meaning that angle right there. There's really 3 options for what it could mean. So this is not an acceptable way, because of the way this diagram looks, to describe this angle as angle P. Hence the word ambiguous. Ambiguous means unclear. If you tell me angle P, I don't know if you mean this angle, or the entire angle. There is one way that we could still just use one character to describe that angle, though. We could call it angle 3. That is clear that we are only speaking about this angle right here. Angle P is, P is a vertex of multiple angles, but that angle 3 sits right inside of the angle we're trying to describe. It could not be confused with any other angle. How else could we name that angle that's acceptable? Well, we could do QPM. Notice how P is the vertex, or MPQ. So there was only 3 ways to name this angle because there were other options for angle P. So these 3 are perfect. I guess there's only 3 ways to name angle QPM, or angle 3. Okay, so just be mindful of that ambiguous case, because sometimes if you just use 1 letter, things might not be clear. If you want, you can always use 3 letters, and then you will always be correct, and you will always be clear. Congruent angles have the exact same measure. This symbol, it's like equals with a squiggly or a tilde above it, means congruent. Okay, so that symbol means congruent. And what congruent means is equal. So if we're talking about congruent angles, we're talking about angles that are the same measure. And in this case, if we're talking about angles, measure, we mean the same amount of degrees. So for instance, if, let's say this was a 17-degree angle, and let's say there was this kind of marking right here, and then this kind of marking right here. Well, what we would say is this angle, since we're told it's 17 degrees and it has this one single mark on it, since this angle has the exact same single mark on it, it must also be 17 degrees. We would say that these two angles are congruent. They are the same measure in degrees. Now, in the second example in the bottom, just like in the first, we can't assume that just because these angles look the same, that they are the same measure, that they are congruent. We can't just assume that. So, unless we're given or told something else, we can't say that these two angles are congruent. But let's say you were given this. Let's say someone told you angle ABC, and then this new symbol, which stands for congruent, angle GEO. If you're given that, if you're told that angle ABC is congruent to angle GEO, then even if they're not drawn to scale, which they kind of look like they are, then we can say that these two angles are congruent. And then what we should do, the minute we see this, the minute we read this, if we were given this, let's say, what we should do is we should mark these two angles. Notice how I'm marking on the inside at the vertex, because we mark angles on the inside, showing how many degrees they sweep out. We could put the same marking, whatever we put here, this is like Adidas less a stripe, we would put Adidas less a stripe here as well. So angle ABC and angle GEO are the same. Why? Because we were told it. So it's very important to understand congruent angles have the same measure, and to mark on the inside at the vertex to show that they are in fact the same. They have equal measure. So we just finished reading about congruent angles, and now we have this new term up here, angle bisector. And if you kind of break it down, you see the word angle, bi, which means two, like a bicycle has two wheels, and sector, which means parts. So what does an angle do? Well, it's angle bisector do. It's an angle by two parts. So angle two parts. It's an angle that's split into two congruent or equal angles. Since it is an angle bisector, notice how the word angle is right there. We are going to get two congruent angles. You'll learn later about a segment bisector, and then you'll get two congruent segments because the word segment is there, so a segment is being split. Here an angle is being split, and so what do we get with an angle bisector? We get two congruent angles. That's a kind of shorthand way for me to say all of these words right here. An angle bisector splits an angle into two equal parts. Equal parts in terms of angles means the same measure. So if we're told something like ray OP, which is right here, it bisects angle EOM, we should get two equal angles. So the best way to have success in geometry this year is when you're given a pile of givens to just look at the first given. Usually that's the most important. That's why we give it to you first. So notice how there's information on angles that have X's in them. Do not worry about that. Do not jump to algebra. You need to focus on geometry. So this juicy bit of information we need to mark on our diagram. You always need to mark your diagram first. Why? Because this is a geometry class. It's not an algebra class. So this given, since we now understand what an angle bisector does, we can mark in that this angle and this angle are the same. Now, I'm going to just focus on the important symbols in this region right here. See how it says bisects and then there's an angle symbol? Bisects an angle that means you're going to have two congruent angles, which means we have an angle bisector. Don't let this ray confuse you. This ray was placed in such a way to cut this angle into two equal parts. However, sometimes students think, because that ray kind of looks like a line segment, they think that this angle that is being bisected, they read that, and then they want to mark these two rays the same. And that does not make sense. We're splitting an angle into two equal parts. We aren't saying the rays are congruent or the line segments are congruent. That is not correct. So do not do this. And this is a very common mistake. So it's good to learn from mistakes early and often. So we have shown that we have two equal angles. Remember, we mark angles on the inside near their vertex to show that they're equal measure. And then we can fill in the rest of the problem. Angle MOP, notice how O is the vertex, so I'll write this information right near the vertex. Angle MOP, so I'll write it at angle O, is 10 minus 3x. I'll put a check mark next to each given. That's a great habit. And then angle POE at its vertex, POE, angle PO, will write in at that vertex 6x plus 28. Now, if you approach every problem as deliberately as we are approaching this problem, you will be successful in this class. Why? Because we've marked everything up on the diagram. We reacted to the angle bisector by showing the angles were the same. And then, and only then, after we marked everything up, we put in some expressions. Then we can finally deal with the x's and solve for x just as the problem asks us to do. But not before we pay close attention to the geometry. Now, if we know that an angle bisector splits an angle into two equal angles, well, that means we have two equal angles. So they have equal measure. One of them is 6x plus 28 degrees, and the other is 10 minus 3x degrees. So we can now set them equal and solve for x. This will be an exercise for you, the viewer. Try to solve for x by maybe moving your x's to the left and your numbers to the right, and then take x and plug in to figure out this entire big angle, angle EOM. So you have to plug in x into both of them, and then figure out how big this entire angle is. So always make sure that you mark your diagram first, and you react to your givens. Again, an angle bisector splits an angle into two equal angles, which is why we marked this diagram appropriately. So here we'll go over different types of angles. An acute angle, let's say I tell you that this is acute. This acute angle must be less than 90 degrees. So for instance, this angle could be 43 degrees if we say it's acute, because that would be less than 90. Or it could be 1 degree, or 0.2 degrees, or 89.997 degrees. These are all examples of an acute angle. And some people help remember it by thinking of the word cute, because that's like small. Maybe think of like a little Pokemon or something. Acute, small. So it's a small angle, it's less than 90 degrees. An obtuse angle is a big angle. That's an angle larger than 90 degrees. And a right angle is an angle that is exactly 90 degrees. Now, I've already started to allude to it in this lesson, but when we're measuring an angle, we're kind of looking at how much of a turn has gone on. So here, this is a ray, but you could also think of this as a 0-degree angle. Imagine I had a ray stacked on top of a ray, and I asked you how much turning occurred between those two rays. You would say 0. They're stacked right on top of each other. So degrees, though, we measure the amount of turning. So for instance, this is a 180-degree angle. See, I have a ray here, and then I did a half of a turn. This ray started here, and then I spun this ray around so that it was looking the other direction. That's 180 degrees. That is a half a turn. And remember, think about Shaun White and snowboarding or something. Doing an entire circle is 360 degrees. So here we're doing half of a full turn. Here's a 0-degree angle, which is kind of weird to think about. So the special right angle, which we mark like so, is exactly a quarter of a turn. And if you think about it, 90 times 4 makes 360. So if we had this ray here and then we pushed it perfectly vertically from the horizontal, we would be making a quarter of a turn. That's a quarter of a circle, 1/4 of a circle. So here, this obtuse angle, let's say this is 117 degrees. That's how much turning occurred from this ray to that ray. Or you could think about it from this ray to that ray. And this guy, I think I was thinking it might be 43 degrees. This is a small amount of turning, our acute angle. We need a little bit more vocabulary here. This 180-degree angle is also known as a straight angle or a line. So now we have all the vocabulary down. And this should feel like a review for you. Now we're going to learn how to classify triangles by their angles. We just learned about acute, obtuse, and right. Now we will apply those names to triangles. So this is a very, very important reminder, and you need to know this forever. The sum of the angles in any triangle is 180 degrees total. That's a very, very important idea, and it's going to show up time and time again throughout this class. So like in this triangle, if I wanted to classify it, if I wanted to name it based on its angles, I would have to get up to 180 degrees in total. If I've used 111 and 39, that makes 150 degrees total. Then to get to 180, I need 30 more. Okay, so before I do anything, I have to figure out all three angles. Otherwise, I might accidentally misclassify. Now that I have all three angles, using this important idea up here, we can look at all the angles and we ask ourselves, are any of the angles larger than 90 degrees? Why, yes, one of the angles is larger than 90 degrees. That means that this is an obtuse triangle. Okay, let's again determine all three angles first before we classify it. Because right now I see an angle that's less than 90, an angle that's less than 90. I might think that this is acute, but if I add these up, I get 90 degrees. In order to get to 180 degrees, I have 90 degrees left over. Oh, so this actually isn't an acute triangle. If I look at all the angles, are any of them 90 degrees, or are any of them bigger than 90? Well, yes, one of them is 90 degrees, so we can mark that in appropriately. That's the right angle symbol. It kind of looks like a right angle, really. This we can now classify as a right triangle. Why is it a right triangle? Because it has one 90-degree angle. Okay. This third triangle, all of the angles are less than 90, so we would call this an acute triangle. And last but not least, you might feel like we've classified or we've named all of the possible triangles, but 60 and 60 make 120. 60 more makes 180. Oh, notice all of these angles are the same. So they're all the same and they're less than 90. But really what's interesting is that they're all the same. This is known as an which means same, angular, which means angle. This is an equiangular triangle. Why? Because it has equal angles. All of the angles are 60 degrees. So this is a very special triangle that won't happen that much. It is actually acute as well, but to be most specific in our classifying or naming, we should call this an equiangular triangle. Now here's some practice for you. Make sure that you draw the diagrams, write out these problems, and complete them, because you should be able to complete them based on everything that we've gone over in these videos. So good luck. Make sure that you do both of them, and thank you for listening and watching.